Hi, everyone. My name is Snegha. I'm a senior security specialist at Okta. Thank you so much for joining us today. We're here with Joe from Doximity to help us talk through automating identity across dynamic infrastructure using our Advanced Server Access product. We're really excited to have him here and learn more about how this deployment has gone for them, and also just give you some insight into the new features we've released and how you could maybe use this in your environment. For the agenda today, we're going to go through, of course, some introductions, why Okta Advanced Server Access, automation, deployment, and then, of course, some best practices, takeaways, and features. We hope this is going to be a really insightful presentation. At any point of time, you're able to use the Q&A to help us ask questions and answer them. And with that, I'm going to hand it to Joe to introduce himself and kick us off.
Thank you. Hi, as Sneha said, I'm Joe Armstrong. I'm a senior DevOps engineer working on the security team at Doximity. So before we get started, let's just do a little intro of who Doximity is. So at Doximity, we are the largest professional medical network with over 70% of all US physicians as members. Doximity provides its verified members with digital tools built for medicine, enabling them to collaborate with colleagues, securely coordinate patient care, stay up to date with the latest medical news and research, and manage their careers. So at Doximity, our mission is to help doctors be more productive so they can provide better healthcare for their patients. So before we start talking about how we've implemented and used ASA, let's talk about where we started and where we began and why we chose it. So when we started, we had a 20-point process to get a new user onboarded and using SSH. Do some walkthrough and touch on the pain points. So a new employee would start, and during their first week, they'd read onboarding documentation and see that they need to use SSH to perform their job. So they would then follow a document, create an SSH key, then open up a ticket for an access request. From there, the IT or security team would then triage that, see which memberships they had and what teams they needed to be on. Then they would create a new GitHub PR, and then we would go through a CI/CD pipeline with Chef to then deploy and create that user account. Once that was created, they would have restricted access, and IT or security would notify them that now you have an SSH account, it has some restricted access, but you can start using it. After a certain period of time, we could graduate them to greater access. And then we need to repeat 7 steps again. They need to let us know they needed more access. We go through that approval process, CI/CD pipeline, and then a user would finally have full access to SSH. So as you can see, this is a slow process. There's 20 steps throughout the life cycle of a new employee joining the company, and it has many steps, many pitfalls, and there's a lot of manual intervention that needs to happen along the way. So as we looked at solving this problem, we looked at different ways that we could do that, and we chose ASA. So why did we end up choosing ASA? There's 5 big reasons. Number one was the first class Okta integration and support. We wanted it to directly integrate with our identity provider and make sure that we had a single source of truth for what an employee needed access to. With that, we got that native extension for the Okta lifecycle management. Instead of having a user need to remember that they needed to have more access, we could automate that and make sure they went into different groups. Then, removing the CI/CD pipeline, we get near instant provisioning and deprovisioning of SSH users. Instead of them needing to create a key and a request and going through a process of deploying a chef recipe, instead, we could let ASA handle that and do it on the server itself. Next, we wanted an API, which ASA provides, to customize the tool to our workflows. We have some auto-scaling needs, and we love that it has an extensible API that allows us to meet those. And last, it replaces that legacy error-prone process that's fragile, has a lot of steps and a lot of manual intervention for users and for the security or IT team along the way. I think one sentiment that's bubbled up through our team and others is that adopting Okta ASA has been a great quality of life improvement. It's made everyone's lives easier and allowed us to focus on doing our jobs and not on doing access requests. So where are we now? So we've taken that 20-step process and condensed it into 5 with a ton of automation built in. So first, a new employee starts as they do. They read some onboarding documentation, see if they need SSH to do their job. Now, They configure Okta ASA on their own. The lifecycle management creates their user account without them knowing, and then they can start using SSH to perform their job right away. And then an employee, once they're our company for a certain amount of time, they're automatically granted more access. So we can finally take what is an internal company goal, providing self-service to systems, to heart, and allows an employee to really just start doing their job right away without the need of the IT security team to help them. So this really helps us fully automate all that provisioning and deprovisioning of the accounts and permissions for users and give that self-service while preserving least access privileges. So we only need to give them access to what they need to in a safe and secure manner. And last, it removes all that approval and workflow that the IT and security team need to do along the way.
Joe, that was some really great insight. I just have a couple questions for you.
Yeah.
Um, you talked about lifecycle management, and I think that's really made a difference in your environment. Other than lifecycle management, were there a couple of things that it felt like really changed the time to value for a lot of these things for you?
Yeah. A big one was removing that CI/CD workflow and really building in the user creation and deprovisioning into the SFTD service. So that really speeds up a lot of the process for autoscaling, which we'll touch on in a little bit.
And with that, Joe, you talked a lot about, lifecycle management. And I think, just to kind of go through for the group here, what the feature looks like and how it works, just from an Okta ASA perspective, I'm just going to go through really quick what that looks like. And this is something that Doximity has set up and has been using. And we're going to learn more from Joe as to how they actually deployed this. So just to go through the background on how this LCM actually works. Advanced Server Access is a downstream application in Okta. It uses UD at its core as the source of truth for the users with their attributes and group membership, the best of which you know in Okta. It's extensible and you're able to add as many attributes as you want. We use Skim to make sure that the users and groups are pushed downstream to ASA as an application as a whole. The ASA admins are then able to go into the portal and configure which groups have permissions to access which servers. These are set up in the format of what's called a project. And think of a project as the group of resources organization that they can then have access to based on their group membership. Each server is enrolled into a specific project via a local agent that sits on the server itself. Using that agent, it's enrolled into that project and then access is created to that. This agent periodically calls out to the ASA API to check, hey, is there any changes that are coming to this user's identity or memberships or what they have permissions to, and it's able to update that according to this. What's really cool about doing this at scale is we're talking about, one in this picture here example, but think about this in thousands and tens of thousands and hundreds of thousands of servers enrolled. Once the agent is installed and enrolled, any change in Okta is picked up pretty much instantly and reflected across the whole fleet. With this model, you can really see that you can stop worrying about provisioning, deprovisioning, and Okta ends up helping you manage your joiner, mover, leaver scenarios via automation, not just for your cloud apps that you're used to, but also starting to bring in your server resources that you can start to use the same way through server access. So with that, Joe, I think this is something you must have gone through a lot when you were thinking about lifecycle management. Can you talk us through how you did a couple of those things and how you adopt that in your environment?
Yeah. So let's talk about how we're deploying that agent in an auto-scaling environment into our servers. The first question that we had is how are we provisioning ASA agents on new AMIs, on images, and new nodes? What's the best way to deprovision those nodes when they're spun down in an auto-scaling group? How are we going to provide the best method to provide logging to visibility to all operators? How do we handle deploying to a multi-account AWS topology? And how do we support teams with different config management needs? We're looking at these 5 questions, and let's touch on how we solved all of them. So the first is auto-scaling and how we're deploying that with different config management needs. So Doximity, we use Jenkins to glue together a few different processes. It schedules an AMI build, and then we use HashiCorp's Packer to create AWS AMIs. Chef, in part, does all the configuration management during that process, and that's installing the ASA agent in that AMI. Once Packer finishes up the AMI creation, It's available for auto-scaling groups to then boot and use. Before it's fully available, a script, the user data script, configures the instance to make sure it has the right host name, restarts the process, and make sure it's available in ASA to use right away. The YAML file that configures ASA is very easy and simple to use, so we provide a paved path for consuming teams. So that way they can see examples of how they deploy in their environment, and they can use different provisioning options, be it a bash script, default chef recipe, or if they wanted to, an Ansible playbook. Providing that kind of paved path on what the default configuration in your environment is the easiest way to make sure everyone can consume and use it in the scalable fashion that they need. So once we spin everything up, it must come down. So we had some deprovisioning considerations we wanted to look at. We wanted to make sure that as soon as a node was spun down in EC2, that it would immediately be spun down and not available in ASA. There's a slight lag, so we built out a tool to do it. And we've open sourced that everyone could use. It's on our GitHub profile, and it's called ASA Cleaner. So what does ASA Cleaner do? It's a Lambda as a Terraform module running on some Ruby code. And it listens for all EC2 termination events. And when that termination event is triggered, it triggers a Lambda. What that Lambda does is it searches your ASA projects, and then it matches up with the ASA API, which stores all the instance IDs of the EC2 servers, and then finds it and deletes it, and makes sure that your ASA inventory is immediately up to date with what's running in EC2. So this really meets our needs as we're triggering thousands of termination events every day, and it effectively scales out to multiple accounts. All you need is a Terraform module with a API key in ASA, and you can immediately deprovision servers as they spin down in EC2 and make sure your inventory in ASA is always up to date in a timely manner. So as we're spinning up and spinning down nodes, we're doing it in multiple different accounts. We have a multi-account strategy for deployment. And we find the two different methods of enrolling servers in ASA is really good in two different use cases. So token enrollment for different projects is great when you're working with a multi-tenant VPC. A VPC that has multiple different projects or multiple different segments that you need to do with role-based access control. It's as easy as setting up those projects, creating the enrollment tokens, and making sure that servers know what project they have access to so they can make sure they're segmented correctly. On the other side, cloud enrollment really works best when you have a single tenant VPC. There's going to be one usage for that VPC, and one AWS account, so we can set it up in the UI, and then as soon as an agent is spun up, it's immediately available. Likewise, if you use that in multi-tenant VPCs, additional role-based access control is needed, and we find that works best in some cases like Kubernetes, where you have IAM security uh, boundaries that are put in there in addition with that, which makes it a lot easier to provide that cloud enrollment and maybe a mixed tenant environment that wouldn't work for token enrollment. So as we're deploying all of the nodes and agents everywhere into all the different accounts, we want logging to everything. We have some great logging available to us. The SFTP journal logs are giving you all the information about who's being added and removed from servers. Your auth logs are telling you what's happening with sudo permissions. Okta syslogs are telling you who's logging into the app, who's using a 2FA request to do that. And then last, we have our audit logs from ASA, which provide a wealth of information that's really nice to see who's doing what and help debug if maybe there's an access issue along the way. So, like the ASA cleaner, we created a Lambda and a Terraform module that allows you to consume all those audit logs and ship them out to CloudWatch, or in our case, Sumo Logic, our logging provider of choice. So what this does is on a regular interval, 15 minutes, by default, it just reads through those audit logs and consumes them and then puts them out to CloudWatch so you can consume them and read them and bring them into a single view. And in our case, we can bring all four of those views into a single dashboard in shared searches. So you can really get that holistic view of what's happening with SSH authentication in your environments. And it's really helpful to get all that from an operator perspective. So if a user's having trouble logging in for the first time, you can see that hey, you logged into Okta, but it doesn't look like your client came up in ASA. So let's troubleshoot that. Or, hey, I'm not having permissions that I need. Maybe we need to add a sudo entitlement to your project. So bringing that all together really helps and makes it easy to figure out and make users' lives easier. So as we just talked about how we're deploying to multiple different accounts, spinning up and down nodes and logging all of it, we found some best practices along the way. And we want to touch on two of the main ones that we see. The first is the initial AMI building and enrollment. So we think Packer is a great tool for doing this, but along the way, we've just run into a few things we want to make sure everyone knows to do. The first is always use that built-in disable auto start file. But make sure that when you're building out the AMI, you're not accidentally enrolling ASA nodes in a project that doesn't need to be used yet because it's just an image. That tool just allows you to make sure that that process doesn't start on initial boot and install and makes life easier. After that, with some automated fashion, always restart the ASA process with the initialization script that you're running in auto scaling mode. Just make sure that ASA is using the most recent host name. There might be an automated one in your AMI build. So you just want to make sure that it's using that and your inventory is up to date with the correct host name at all times. Last, make sure you create a few different paths via some logic, maybe in configuration management, to allow for token versus cloud enrollment in your environments. So just providing that mechanism to say this environment is cloud and this one uses token with projects makes life easier so you can make sure that you're always enrolling the correct way in each of the environments you use. So we're fans of pseudo entitlements because it really makes it easy to provide people that least privilege access in a really automated fashion and in a fine grained control. So we have two big use cases that we use it for. The first is developer permissions to manage apps. So we can give an engineer the ability to restart an application and look at that application's log on a project and group level permission that we didn't really have before. In addition, if there's other use cases where a team or a mix of teams needs to manage another service that's not standard, we can easily create a pseudo entitlement that allows them to restart a service, look at logs, run a command, etc., in a great fashion that allows just that fine grained control, allow them to do their jobs without us needing to help them. So these are kind of the best practices we found as we've deployed ASA into our environments that we think will be really helpful for everyone else to use.
Thank you so much, Joe. I think that's exactly the kind of best practices that make a deployment differentiate from, being successful and being hard to implement. Just a couple questions for you as you've gone along on this journey. We really appreciated the partnership in getting feedback and also just understanding how we can improve our products and things. And before I jump into a couple of feature highlights, I wanted to ask, has there been anything that stood out to you as wish Okta had this, or really love this?
Yeah, so I think one thing that we would love to see is just maybe some more tag availability in that ASA API, just so we can get a little more information about what servers have information for just the way we kind of organize tags for EC2 instances. Because right now we kind of just get that EC2 ID that we're using.
That's great. And I think segues perfectly into some of the features that we wanted to talk about. Again, really appreciate the insight here before we kind of jump into just a quick recap of what ASA looks like in our environment. So, jumping right into what Okta ASA architecture looks like in your environment, you may or may not have already seen this today. So, ASA is an integrated application completely built in with Okta, leveraging the full power of all things Okta. This includes the directory, so UD, it also includes MFA, any contextual access, anything else that we would do for all the applications that you're used to in Okta. We're able to start transforming to the SSH and RDP layer. The ASA control plane and core services are delivered again from the cloud. So this is not something you go and have to host in your environment. We ship three services that are deployed alongside the customer's environment. So the client application, this is what sits on, if I'm an end user on my machine, for me to have seamless access behind SSH and RDP. What's actually happening is it's interfacing with the local SSH and RDP protocols to gain that access. The server agent itself, we just touched on this, it sits on the actual servers. And what you're able to do is it manages local accounts, permissions, audit events, and optionally, we also install a gateway service that's used for our session capture feature, which I'll touch on in just a second. SSH session capture is a feature that's more recent for us, and it's something that really helps understand how you can take a step further with some of your deployments if this is relevant to you. The new feature includes being able to capture SSH sessions through a gateway service to meet advanced compliance requirements. So if you have a need to be able to trace back what's actually happening in every auth session, you're able to use this. The gateway service is deployed across instances in the customer's environment, usually in an auto-scaling group that like we talked about. Servers are configured to pass SSH traffic through these deployed gateways. These gateways are then able to capture each session at the command level and then deliver the logs to a secure object storage location in the environment that you want it to be stored in. Okta is never able to see these logs, providing tamper-proof evidence of user activity for any compliance audits that you may need to provide these for. The next thing we talk about, I think, goes right into Joe's feedback. We talk about policy sync, privilege access, and a lot of these different things. And hopefully you've gotten to attend some other sessions and keynotes to understand how we're investing in this space as well. Policy sync is a class of features that combine role, attribute, and time-based access controls to give you a flexible model for applying access policies. New to ASA is attribute-based access controls, which allows for more fine-grained access policies based on labels. For example, select groups can only access servers labeled PCI. These labels can be automatically imported from connected providers like AWS, GCP, and Azure to follow. So we'll be doing AWS first, but we will go to GCP and Azure as well. So customers who've invested in resource tagging in your cloud environments already, you'll be able to bring this to ASA out of the box versus having to duplicate that effort in resource management. With that, these were a couple of the highlights of some of the recent features. And as you can see, we've really been looking at how can we transform not just your access needs with the applications you're used to, but also really think about infrastructure as a whole. And hopefully using this session and several others that you may get to attend and some of the advice you've received today, you're able to understand how you can either further your journey with ASA or maybe even just start taking a look at it. With that, Joe, any last comments for us from your side?
No.
Great. Thank you so much for your time. We really appreciate it. And for everybody in the audience, thank you so much for joining. And we're going to be available via chat for any questions you may have. So please feel free to ask questions or even provide any feedback. We're here to help. Thank you.
Thanks, everyone.